In an elimination reaction, atoms are actually removed from neighboring carbons. So atoms are removed. So this is basically the opposite of addition. So now we're removing. So we're forming multiple bonds. We're forming double bonds. And we'll have two products. We'll have our alkene and whatever molecule we just removed. Now these do require catalysts and sometimes heating. For instance, if you have an alcohol and you treat it with a strong acid, like sulfuric acid, you can produce an alkene and water. If you have a halo alkane and you treat it with a strong base and you heat it, you can produce an alkene, a salt, and an alcohol, depending on the base that you use. If it's an organic base, you can form an alcohol too. But you're removing the halogen and another atom, another hydrogen. So these are pretty much the reverse of addition reactions. If we treat ethanol with a strong acid, we will get ethene and we will form a molecule of water. Both carbons have to lose an atom. You will not lose the hydrogen from the same atom as the OH. So if we have chloroethane, and we treat it with sodium ethoxide, which is a strong base, we will form ethene plus sodium chloride plus ethanol from the ethoxide part. So we would remove one H from this carbon, one chlorine from this carbon. The sodium will bond with the chlorine and the hydrogen will go on the ethoxide portion. Now what happens if you've got more than one possible place to lose a hydrogen? Because here we could lose a hydrogen from this carbon, or we could lose it over here on this neighboring carbon. So which one's most likely to occur? Well, the rule is the carbon that has the most carbons bonded to it is most likely to lose the hydrogen. So we have two products that are possible. One of them is going to be predominantly produced, and the other one is going to be not produced as much, but we'll still have some of it. So what happens is the carbon that's bonded to the most carbons will lose the hydrogen. So this carbon here is only bonded to one other carbon. This carbon is bonded to two carbons. So we're going to lose this H. So what happens is we keep that first set of hydrogens, and we're going to lose an OH and an H, and we form a compound, an alkene, plus a water molecule. Now here, I've drawn cis. This is cis butene, or cis 2-butene, because the hydrogens are on the same sides. You can also form the other geometric isomer, and that would be trans 2-butene. So here the hydrogens are on opposite sides of the double bond. So this one is trans but 2-ene. I must have spelled this one wrong. Okay. So these are the two major products, and the other product you'll make a small amount of is 1-butene, where the carbon double bond is after the first carbon. So but 1-ene.